paid.
I have a friend that's a project manager. So the new and he said because he offered me a DevOps. And then in the end, nothing happened. I said, no, sorry. Removing everyone. To 200, 250 devs, and no, and they're going to focus the guys in London because always
or you can effectively say, well, that
we will know
side a further
because this guy has bought
and then as they do more and more
parts of Europe.
So and it's like, oh, you have not half your
interest
that's actually in that term.
They can do it. They have the money, they have the access.
Yeah. And then, I thought that would be quite an interesting way if you can come up with a way.
We said it. One that we did.
He doesn't get it. He doesn't get it. Unfortunately, knowing you don't know you and then you are actually going to be on 10 times.
So actually, Becky is doing it. Yeah, all 100%. I'm happy to take these to go out and start getting that way.
Yeah, I think maybe it doesn't.
Yeah, that's the beauty of it. You build your tool, you build your
And actually, it's
rather than your competitors.
All right. Gather rounds. Gather rounds.
It's called Tim that.
All right. We have quite a cozy audience. It's understandable for December, but thank you for coming. This is our first year of this thing we're doing here being called BDD Meetup. Before that it was called Meetup, which is basically focused on one particular tool. And since then we expanded it and we had a whole lineup of amazing speakers and amazing people coming here and sharing their experiences. People like Liz Kyo, Dan North showed up a couple of times. So a lot of interesting things, and we're planning to do even more of that next year. Now, that said, there is a point where enough speakers from NVICA is enough, and we kind of need more people that want to share their experiences with BDD or around BDD. How do you do with test-driven development? How do you do with behavior-driven development? How do you align your understanding with the businesses? If you have anything to say about that, please tell us on the Meetup group and we will align you to speak about it. If you needed any help in preparation for the speech or the talk, feel free to ask for that. We're always ready to help. Meetups happen every second month. Now, the next meetup might happen in January. We have potentially very great speaker line for that, so keep an eye open for this. It's not confirmed yet, but if it happens, that will be very, very awesome. Today we have amazing talk for you lined up. I wouldn't say amazing speaker, but amazing talk.
Speakers are
So Boaz Taal is someone that I have a very great pleasure working with for the last almost 3 years. He's a director of business development at Enigma. The first time I've met Boaz, we had a very interesting conversation. I just arrived and it's like met everyone at Enigma the first time, and I was presented as a BDD expert. And Boaz, by the way, director of business development is just a fancy name for a salesman. Not being condescending at all. He approached me and he said, "So this BDD stuff, does it mean that we'll need to build artificial intelligence as the next step?" What do you mean? How does it connect? And he's like, "Well, you need to build automation of predictive model for human behavior as the next step in order to automate your BDD scenarios." It's like, how did you come up to this conclusion? And he's like, "Well, you're writing your BDD scenarios where you're basically describing how human interacts with the system and what the system responds to human as an outcome. And then when you start automating those scenarios, you're checking that the system actually responds in the way it should respond to the interaction that you assume people will do. What you don't automate is, do people actually do those interactions? And do they actually act in the way they should act with the system? And in order to verify that, you need to build artificial intelligence for this." That was a very interesting and simple discussion. Yeah. And I'm really happy to see Boaz basically developed into a more full-fledged talk on that note. And that is what the B in BDD is about. So please welcome Boaz.
So, just to give a bit more context, we're not going to talk about artificial intelligence, I promise. My interest in software development started about 30 years ago. So I was trained as a software developer in obscure languages like Pascal and Fortran. COBOL as well, yeah. And then the PC arrived, so I actually worked on mainframe computers, which was very boring. And I decided it's not for me. But in the last 30 years, I was fortunate enough to work in industries that went through digitization, transformation from being very manual and analog to very software-oriented. Pretty much every industry went through this process. I was initially in TV, connecting computers to screens and running numbers, real-time numbers on screen, which was very exciting 30 years ago. Then telecom, and recently at Enigma, general purpose web application. So I enjoy seeing people struggling, if you like, with how do I take what I understand in the world and how I take what I understand with how people behave and try to explain it to developers. And that's my interest with BDD is exactly this bridge, this conversation that goes on between what I want the system to do and what I expect the people to do with the system. And I ask Konstantin and other people at Enigma, what do you actually mean behavior? When you say behavior, what do you mean? The answer I got initially was that behavior is the action of people and the reaction of the system. So when we talk about behavior, we sort of couple them together. We assume that people act in a specific way, and therefore the system needs to react in a specific way. Is that a sort of good enough definition? Yeah? Okay. So the problem with this is that we know how to tell the system how to react. And therefore we assume that we know how people will act in the first place. We're basically designing a system based on the assumption of what people will do. And we want them to do it. We really, really want them to do it. We build beautiful systems, beautiful interfaces. We really want people to interact with us in the way we design the system to react. But that's very much from a system perspective. That doesn't really take into account how people act in the first place. We just assume that if we'll build a beautiful enough, well understood, simplified system, they will use it in the way we expect it. And the problem is that we know from experience, because looks like all of us here have written a line of code or two in our life, we know that this just doesn't happen. And with BDD, we do something really, really good. We sort of ignore how the system needs to be built, and we're only dealing with the input from the users and the output from the system. So this is what you call in system design operational view. We sort of focus on the boundaries of the system, understand the domain the system needs to operate in, and only then start designing the system. So let's talk about the system we understand first. Where does it come from? How does it think, in a way? So, as you probably know, this guy, Alan Turing, came with the concept of the Turing Machine, or the machine that can do anything as long as you feed it with the right program and an infinite long piece of paper. And when Turing talks about machines, he used the definition of a mechanism that processes computable numbers in a mechanical way. So that's the definition of Turing machine. Everybody familiar with this? I'm not talking anything new here, right? So this machine has a program, it has a tape, and it has a head that reads the data, reads the program, interprets the data according to the program, and writes the output. That's, if you like, that's the operational view of the system. It can do anything as long as these three elements are provided. And it's a mechanism, and the dictionary definition of mechanical or mechanism is operated by a machine and done without thinking. So the machines we design, the systems that we work on and design the outcome of, or the response of, are not thinking by definition. But the problem is, of course, that people do think. So we have this classic conundrum, it's one of the most known conundrums in philosophy, where you have a discussion, what is, is the world deterministic, or is the world its free will? So we agree that the machine we design is deterministic. It won't do anything we didn't tell it to do unless it's an error. And even that is deterministic, because obviously once you see the error message, you know that you know what you need to fix in the machine. So even the error is deterministic. But we also assume that people have free will. They think. So we have a free will system interacting with deterministic system. How do we deal with it? What's the common way of dealing with it? We first assume that this contains certainty, and we're trying to achieve certainty. Even BDD is an attempt to increase the level of certainty about the design of this system. And we assume that this has a lot of uncertainty. People behave in an uncertain way. They always surprise us. The users always surprise us. The users always come up with one thing we didn't think of, and we have to deal with it. So actually, we're a bit more rude to our users. We assume they're a risk. And I'll give you a simple example. Anyone that design a form know that we start putting we start putting validations. What is validation for? It's based on the assumption that some user, if not most of them, will put the wrong data into the field, and we have to deal with this risk. And the problem with dealing with users as risks is that it creates very unhealthy relationship between us, the engineers, and the people that we actually build the system for. And if we look at a very sad example, in my view, of people that design systems and then deal with users as risk, is economists. Economists had this amazing view, or have this, some of them still have, this amazing view about a perfect world where if everybody behaves in a pure logical way, the world would run fantastically smooth, right? So if the supply and demand meets at the optimal point, the price will be right and everybody will buy and it will be great. The problem is that users are stupid, they're a risk, and therefore it's their fault that the economy doesn't work. The economy is trying to force reality on the users, and to deal with their fantastic models, they invented this Homo economicus, who's the perfect logical person, and with him, it's working great, not with others. In IT, this issue, how many people here worked on a system that was beautifully designed and architectured, but every user that used it hated it with passion? Yeah. a couple of us, right? How many people here worked on systems that were fantastic, but no one used them? They were just given out and no one used them. So this is the problem of dealing, in my view, dealing with users at risk. So what I want to do today is to try to suggest a different way to think about users, a different way to deal with this conundrum between free will and deterministic machines. Let's go back to this, certainty and uncertainty. That's sort of a given, right? We work on certain systems, or try to work on certain systems, and user behavior will be uncertain. So how can we take a different view? We can think about it in different terms, which is predictable and unpredictable. With BDD, we're trying to predict this behavior, and we're actually quite, I think, from what I see, compared to other experiences I had with the software development teams, when you do BDD properly, you get more predictable results. You are designing a system that can produce predictable outcomes. So now we need to think about people as unpredictable. They're not a risk, but they're less predictable than our system. So I want to go back to an example that Turing gave us to try and define how we move a bit further in understanding our users. So everybody here familiar with the Enigma Code and the story of how Turing broke it? You saw the movie? You read the book? So the Enigma Code posed a problem for Turing and his team. Basically, sorry?
It was Polish people.
Polish people gave the original idea, yeah. But the Enigma Code, the Enigma machine was a known machine, so the mystery wasn't the Enigma itself. It was a machine available in the market, you could buy it. The German didn't make a secret of the fact they're using Enigma. But the question was, how do they set it up every day? And the setup was based on actually 4 wheels, not 3. But it was very simple. If you set up these wheels, it means that when you press on L, the first wheel produces B. The second wheel then says B equals T, and then T equals E. And the only people that had the code could know that actually E in a reverse way means L. So it was just a typing machine where the letter produced on the message were 3 steps removed from the original letter that you meant to write. Okay. The problem is that when it comes, and then the German added a bit more complexity on it, so they got to the point where this was the total amount of combinations possible. Which is, in normal terms, is 158 million possible settings. For anyone but Turing and his team, this was an impossible, completely unpredictable problem. You can just not decipher it. But Turing was a pure mathematician, so he actually said, well, a Turing machine could deal with it. All I need to do is reduce the number of combinations to a point where the system is predictable. And if I can do that, I can start deciphering the code. I can start breaking the code. What helped him a lot, and there's a nice episode in the film that shows that, is that some German operators used to sign the messages with Heil Hitler using HH. So that helped Turing say, okay, so if the message I'm deciphering finishes with 2 identical letters, there is some possibility. We're not sure, because not all German ciphers did it not all the time. But there was a human behavior that says, okay, so there is a possibility I can assume with some level of certainty or lower level of uncertainty that these II could mean HH. And therefore, I can start reducing the number of possibilities. It's like, anyone here has thought about creating a software to fill lottery. You know, you get rid of all the 66666 and the 1, 2, 3, 4, 5, 6, 7 because they're less likely to happen. Something along those lines. By treating this enormous amount of possibilities not as an impossible task, but thinking about it in terms of how can I make it less uncertain or more predictable, Turing started the process of breaking the code. And I'm suggesting we'll do something very similar. We need to think about how to make our users less unpredictable. And the answer, in my my mind, comes from behaviorism. Behaviorism is this field in psychology and economics and many other social sciences where we actually think about users or people in the same way we developers think about machines. So we basically ask ourselves, what kind of output the user will produce as a response to a given input. We're not trying to understand, like in sort of, let's call it psychoanalysis, why does the user respond in this way? We're trying to observe the system from outside and say, given that I tell the user something or tell humans something, I don't really care how they come up to the conclusion, but I want to observe what comes out. And I try to generalize. The most famous experiment with behavioral psychology is Pavlov and his dogs. Familiar with this story? So Pavlov was I think a Russian psychologist, not Polish.
No.
Yeah. He basically trained dogs. He trained dogs to eat in a response to basically put dogs in a cage, and there was a bowl of food in front of them and a lever, and every time he rang the bell, food would appear and the dog would eat. And he got to a point where he would ring the bell and the dog would drool in expectation for food, even though food wasn't given. So that's an experiment in behaviorism. It's identifying how a system, called a dog in this case, behaves in response to some stimulation. And obviously, when you do any kind of behavior psychology experiment, it's important to make sure which system you're observing, as this joke sort of shows you that. So the question behavior psychology is asking, or behaviors in general, translated to BDD terms, is what are the relevant motivators, enablers, and triggers for John to buy at our e-commerce website? And I think that if we start thinking in these terms, we can start making our users less unpredictable. Because the research that went into this field in the last 50, 60 years is revealing quite a lot about how we can generalize and expect some predictable outcomes from our users. So let me give you, I'm not going to give you the whole set because it's quite a big set, but let me give you some which I think are really interesting tools that you can start using hopefully tomorrow morning. The first and most important one in my view is motivation. So we all talk about motivations, but motivation is highly researched, and we all we heard about carrots and sticks, so we all assume, and we're actually raised to believe, that what's called extrinsic motivations, carrots and sticks, make people act. We know that if we raise people's salary, they work harder, and if we give them a fine, they'll drive slower, and all these kinds of carrots and stick system. In fact, our entire belief system in the Western world is built on carrots and sticks type motivations. But in the last 50, 60 years, there's a lot of research going into intrinsic motivations, things like pride and curiosity and sense of achievements. These are things that don't really show the same characteristics in carrot and stick. Right? A pride is not exactly a carrot nor a stick. It's something that you feel inside you. That's why it's called intrinsic. Interest, curiosity, sense of achievement, flow. I'm sure a lot of open source or developers in general enjoy the sense of flow, which is completely intrinsic. What's interesting about the research into motivation is that it actually shows that intrinsic motivation is stronger than extrinsic motivation. So when we design systems and we think about carrot and sticks, we're missing a trick. If we'll think about intrinsic motivations for people to do what we want them to do, we can probably achieve higher level of predictability. Simply put, if I'll use an e-commerce example, it's very easy to think about how to make the buying process, the checkout flow, as simple as possible, and offer buy one get one free at every given moment. That's a sort of an extrinsic motivation example. But price comparison and other things that sort of give you a feeling of control and interest. Think about how well Amazon did with people who bought this book also bought that book. There's no real extrinsic motivation. You don't get a carrot. You get a price for buying the other book. Actually, you pay more. But it's interesting. It gives you a feeling of, there's more options here. A prime example of using when intrinsic motivations work better than extrinsic. You familiar with the story of Encarta, Microsoft Encarta? About 20 years ago, Microsoft decided they're going to beat Britannica. And they started designing the best ever online encyclopedia. Actually, originally it was on a CD. You could buy a CD with the whole Encarta on the CD. $20 billion later, they shut it down because there was no interest. Around the same time, about a year after Microsoft started Encarta, Wikipedia started. Wikipedia offered no structure, no carrots, many sticks in terms of how much time you had to dedicate to it if you're a writer, but it offered a whole load of intrinsic motivations. If you believe in something, if you like something, to write a Wikipedia entry and actually author it and keep maintaining it and adding more information is quite a rewarding feeling. So this is a prime example where you design a system with intrinsic motivations in mind. They work really well, and intrinsic motivations also work in the way Wikipedia finances itself. I'm sure you all see this big messages, please donate £10. And I hope some of you do, because again, no one gives us a carrot or a stick if we donate to Wikipedia. We just feel good about ourselves. So that's another example of intrinsic motivation in mind. Another area of research is human needs. So I think it's fair to say that as humans, we need. We have this urge to need stuff. And unfortunately, need satisfaction is something that we don't think about too much when we design systems. So the need satisfaction theory assumes that, or argues that, as humans, we seek out and continue to engage in activities that satisfy our needs. There are many different systems you can use, just a checklist or whatever. I chose one, which is the 3 basic human needs. There is the theory of 6 basic human needs, and the theory of the 9 basic human needs, and the Maslow hierarchy of needs, and whatever. It doesn't really matter which system you choose. All I want to stress here that thinking about user needs is very important. So the 3 basic human needs, if you like: competence, I control the outcome; autonomy, I do it because I want to; and relatedness, I interact, therefore I belong. Sounds familiar? Can you know sort of systems or online systems in specific that you're using that answer these needs? Anyone have ideas? I'm trying to sort of... Facebook, true. Successful? Oh, they're doing all right. Yeah. So actually, pretty much all social networks are based on answering these human needs. So this is again an example. If you take human needs into consideration, you can develop quite successful systems, and at very low cost considering the amount of people using them. Any questions, by the way? I'm just rumbling on here. Okay, so another concept that another trick that I think we should get into our books is the concept of affordance. So affordance is a term used by biologists and zoologists when they talk about the relationship between animals and the environment. So if you think about why would an animal stay in a specific environment or move away to another environment, it's because the environment afford what the animal needs in order to live, afford survival. So an animal scans the environment, and you can see there's water to drink, there's a bush I can hide under and get some shade, and I can climb on a tree when another bigger animal is chasing me. That's the concept of affordance. We as humans understand affordance very well. Actually, in human terms, affordance is the predictive properties of something that we look at, object or environment, we just know this is for this. Let me give you an example. A chair affords sitting. We don't need manuals for that. We see a chair, we know this is for sitting. And actually the chair can look very different, and we still know it's for sitting. And it can look even more strange, and we know it was supposed to be for sitting, but we better not sit on it. Yeah. So affordance is something we understand naturally. If we present the system in an affording way, we will understand it. And it was developed like with the animals. It was developed when we were hunter-gatherers. When we walk in any environment, our brain is constantly scanning the environment. It's sort of saying, what is this environment affording for me? The way the brain works is something along those lines. So there's bushes here. So this could be an area where enemy comes from, being a tiger or another human. This is a tree. So if an enemy comes from here, I can run over there. We're not aware of that, but our brains are doing it all the time. There's a lot of research to show that this is actually 95% of the activity of our brains is occupied with evaluation of affordance. Why don't we let's use this power? And I want to give you a couple of examples. So this is a Gumtree car ads. There's very little affordance here. It's basically just I see very few options. So if I'm looking for cars, this will be boring for me. It's not affording a lot. This is the competitor, AutoTrader. Look how many things I can do here. How many trees to climb on and how many bushes to hide underneath. How many different things I can do here. I think that in our race to create simple to use systems, we're losing the trick of affordance. Affordance, together with human satisfaction, need satisfaction theory, if you put them together, is actually calling for systems that require some effort, but offering a lot of reward in return. And there's this tendency in our industry to sort of remove all the obstacles, make it really, really easy for the user, and we're missing those tricks, in my view. So let me give you an example that a system that I like a lot, and I hope you like them too, because they're doing great. Look at the Amazon product page. And let's try to analyze it from the three perspectives I talked about. Let's start with affordance. How many things we can do here?
Check out the reviews.
You can check out the reviews.
To basket.
You can add to basket.
Choose a different color.
Sorry?
Choose a different color.
Different colors. And there's pictures. And there's video. And I can buy it from different providers, so I don't necessarily need to go with the price Amazon is offering me. I can also add it to my wish list, so I don't even have to buy it. And obviously, we know if we can click on the reviews and then we can write reviews, not just read reviews. So there's lots of stuff here, and it goes against the concept of making it really, really simple and really, really clean. But it gives me a feel of control. So let's go. Feel of control. I can interact, therefore I belong. I control the outcomes. I don't have to buy. I can do many different things. And there's a lot of affordance here. I want to stay here because there's a lot of signals to my brain, and actually it keeps me, assuming I'm interested in the bag in the first place, otherwise I wouldn't land here. It's a complicated but complementary environment. So how does it look if I wrote a BDD script to start designing this page? It will probably look something like this. Given the SDM bag has a dedicated page on Amazon, when I check this bag product page, I should be able to buy it. Is that a good start? This is how you would start describing the page? So we're really talking about ability. Where is the motivation? Where are the needs? Where is the affordability? And there's nothing here. We're really, really going back to what I said at the beginning. We're trying to tell the user, this is what we want you to do for us, and therefore we're designing the system for you. What we're trying to do, assuming that the user is here and buying the bag is here, is we're trying to reduce the friction as much as possible. We're trying to make it as simple as possible for the user to climb the hill called buying a bag on Amazon, or whatever is the function we're presenting. I want to argue that we should start with this. that given the STM bag has a dedicated page on Amazon, when I check that this bag product page, then I should be motivated to buy it. Because without the motivation, the user wouldn't even start climbing the hill. So we can design the most amazing system with the least friction possible, but no one will have the motivation to actually start climbing it or even walking the distance between landing on the page and buying it. Sorry.
How can I test that empirically?
Good question. Good question. We look at some of the analytics terms we're using, like dwell time and quality of engagement, are good examples. We recently helped a big weather website that came to us and said, "I have a lot of traffic, but not staying on the page long enough." And we made it more complicated by offering more options, and we increased dwell time. And we increased the number of clicks, so people are using these other functions. They're curious about these other options we offer them. I also think that the success of social networks is a good empirical evidence that systems that consider human needs generate good responses. But to answer your question in a more scientific way, I think the first one is you need to think, what are the relevant motivators, enablers, and triggers, and then start to implement them and see if they work. And it's a trial and error, like everything else. You try something, and if you think that if it works, then you're probably right. So the question is, how do we find those relevant? Who knows? Who knows what are the relevant motivators, enablers, and triggers? In the team that we work with, who knows the answers to that?
So are you saying like you just have to put it out to like live and then just sort of gather a lot of metrics and get like a...
Well, I think that's what we should do anyway, but
That's how you test it.
that's how you test, yeah.
And how you define it.
But how you define it? How do you start? Who can answer these questions? Who can give us the answers?
Salespeople.
Salespeople, yeah. Marketing people, the customer, basically. At the moment, a lot of our conversation with the customer is about functions, about enabling. We don't ask, I think, or don't ask enough, what makes your customer tick? People here, there's someone from Feel Unique, right? Sorry if I'm spotting you out, but so Feel Unique is a company that sells cosmetics.
Yep.
Right. So in your conversations, do you speak about why people buy cosmetics in the first place? No. So you're dealing with how to make it easier for them, or how to make the basket bigger, and how to, but actually it's a key question. Why would they buy makeup in the first place? What makes them tick? And I'm sure that the business people and the sales people and the marketing people know the answers, but we don't ask them these questions. So then, therefore, we cannot create the right tests and test our assumptions. And that's my main message to you is get those people involved. Ask those questions. It will also increase the bond between the sales and the marketing team that pays the salaries at the end. And this is me with my sales hat on, and the development team. We spoke I was in the previous BDD Meetup, and Kieran spoke about creating coherent language for the domain. That's a great way to create coherent language for the domain. Ask these behavioral questions that will increase your ability to understand the domain you're in. So I would want to argue that the future BDD script should look like this. Given the STM bag has a dedicated page and it is ranked 4.5 stars, so there is relatedness, someone else interacted with the page and gave it a ranking, and it presented in black, red, and gray, so there is affordance. There's not just one option. It's complicated, but I can choose. I feel there is options for me, and it has a price from 3 different sellers, so I have an autonomy. I don't have to choose one price and believe Amazon that's the only available price, and so on. And then, given these motivational triggers, enablers are presented to me and are part of the way I design the system, I will be more motivated to buy the bag. I'm not saying this is a done and dusted solution that will appear in Bihar tomorrow morning, but I definitely want to encourage you to start thinking about it. To start thinking and ask, be polite and confrontational with your customers, or internal or external, and say, but what makes your customer tick? What makes them want to buy? What makes them want to use this function? Because one of the biggest problem of our industry is this assumption that we'll build it and they'll come. And we slave day and night and weekends to make things work, and then they don't come. I think that we should ask, when we start thinking about anything, what will make them come? What will bring the motivation? We will achieve much more. So in a pure agile way, I would say motivation over ability.
Can you just go back to the example?
This one?
Like my personal problem with this is that it's hard to measure on the development stage the motivation of the customer. How to it's easier to measure it with like Google Analytics, whatever, later on in production, but for like development purposes, it's like a bit different too, I would say.
Consider.
I have an answer to this. Because Boaz presented it previously. So the kind of automation that we're doing usually with the systems is like with behavior driven development. We usually write a scenarios and then we automate the testing of the system, right? So like essentially you're testing if the scenario rings true when run against your system that you're building. When you're dealing with humans, it's essentially the same process, but you need to run not against the system, but against the humans. So you do go through the scenario and you do define some automation for it, but automation is more based on analytics and actual measurements of human motivation. So you define some channels through Google Analytics or any other analytics like tool set that you use. And then you try things out. So it's like the same way as you're test driving your system, where you're writing like given what then, and then you're trying to run your system. Systems fail. So you add some line of code, you run the system again. It's like one step became green, another step became green. The same process you apply, but at the higher level and at a different kind of system, where you're basically looking at your analytics and you're applying this scenario and you're saying, okay, if we put ranks in, and if the bag is ranked 4 and 5, and then if there's multiple options of the colors, and if there's different sellers, people will be more motivated to buy it. How do we measure motivation? By setting this kind of funnel and metric. And then you run it for a specific subset of the customers, and then you see if it works. And now, a year or two ago, I would argue that it would be very hard to achieve if you just start in your product from scratch and you don't have any customers. But now there are so many like software as a services that just allow you to channel hundreds of users just like by you paying like very small pieces of money, that you can do those verifications even on the product that is not launched yet. Just like make it like limitedly available under unique link, and then buy a couple of hours of from software as a service, like channel people through and see how they react to your system. And then if they don't react in the way you expected them to, change your scenario. And that is exactly the same process we apply when we're developing the system. But now you're not just developing the system, you're also developing a system that motivates or enables people to do the things that you want them to do.
I think there's also, I mean the real test is with users. So yes, the real test is with a live system, and then you do A/B testing, right? But we use BDD to design systems as well. And when we write the given, when, then, we assume that the users will do what we expect them to do, what we want them to do. And then the real test is, the test we're doing at the moment is, does the system react in the expected way? But the user behavior stays an assumption. And you can only measure it when it goes out to the world and user starts breaking it. And we all, the old saying that no system survived the first contact with the user. So all I'm saying is that it will still be true. No matter how much you'll try to predict user behavior, they will surprise you. But I'm trying to advocate for a bit more practical predictability. I'm saying that if we know that intrinsic motivations work better than extrinsic motivation, since we know that need satisfaction theories have been proven again and again and again, we know that affordance is a process that happens in the brain all the time. Let's try to satisfy those processes. Let's try to introduce a much more fine-grained assumptions about the user behavior, and by doing so, reduce the level of unpredictability to a more practical level, a predictable level. It will still need testing in real life, but it will, in my view, generate better thinking about the system in the first place, better definition of user behavior, the B in BDD, and potentially systems that are more surprising, more attuned to the users. And one day I'll achieve my dream, hopefully, of the artificial, what was it? Automated artificial something. One day we'll be able to model a human brain and just test on it before we actually send it out to the world, ship the software out to the world. Users will continue to surprise us even then. But until such point, what I'm suggesting is less about how we test it, it's more about how we think about the users. How we try to predict a bit better what they will do with our system. Any more questions? Someone want to tell me I'm talking rubbish? Please.
Well, no, I want to talk a little bit about what he says. So this is kind of, you are proposing a layer between the BDD and the user. So kind of, we expect that, we want that, and how can achieve it? But there's somebody that has to translate that in a technical language for us to treat it as a BDD.
I'm not sure that the coding tools will deal with it.
Yeah, this is what I'm saying. So it's not automatic.
It's not automatic. It's not automated. That's why I'm saying, one day we'll achieve this automated option. But I'm saying that not asking these questions is missing a trick, and a very important trick. The trick of trying to predict what the users will do with our system. Because let's face it, this is what we do all the time. Every time we write a line of code, it's based on the assumption that the users will do something. So if that's such a key assumption in what we do day in, day out, let's try to make it a bit more manageable. Sorry.
Obviously, what you've got on your screen there's a worked example. How do you compute what's the affordability-ness of a particular page is? Because you would want that stage automatically.
I don't think I'm the right person to answer this, because I'm not writing code for many years, and I'm definitely not a tester. The concept of affordance is my perception of affordance is that we've been busying ourselves too much with making things smooth and simple, and we miss the need for human brain to see more than one option. How do I code it? I'm not sure. It could be actually a UX, the UX part of the system rather than the underlying code. But it's about this make things simple all the time. There's this drive in the industry to make things simple. Streamline the checkout. Streamline the process of getting from A to B. And actually, affordance, in my view, is a sort of another way of thinking about it. Is it right to make everything that simple? If the gaming industry is actually using affordance all the time. If you think about what you see when you look at a computer game, all these options and these things, the different thing, you can go left and you can go right and you can go up and you can change the weapon and change the car, and you spend 15 minutes before you even start the race by configuring your car. This is affordance. Why don't we do, and games happen to be quite successful as well, so why don't we do more games? Why do we get, when we think about processes, we forget gamification and we try to make it as simple and as boring as possible? That's what I talk about when I talk about affordance. Sorry, you would.
Yeah, I mean, it seems to me that you've kind of taken the concepts of BDD and you're like solving a new problem with those concepts. Like, so BDD is about sort of making development efficient, whereas this is about kind of making the ideation of the software efficient.
Mm-hmm.
It's about making, like, sort of what are we going to build efficient as opposed to building it efficient. So it's almost like a completely new methodology you're proposing here.
Could be. But I wanted you to come and listen, so I invented the name. No, actually, I disagree. I think that BDD introduced the concept of the user in a much more efficient way into coding. All I'm saying is that the user is actually a freewheel system, and therefore you need to try and interpret it in a freewheel way. And what I'm saying is that this free will is not completely unpredictable. There are predictable elements of the behavior of the user. But what we're doing at the moment with BDD is we're assuming what we want the user to do for us, and we're not thinking about what we need to do for the user. And when we do, and I think that when we do ask ourselves or the business that wants us to write code, what makes the user tick, we will achieve better answers.
And I think, just to clarify on this bit, the tagline of BDD is not to deliver software effectively, it's to deliver software that matters.
Right.
And there's no way you can deliver software that matters without thinking about the users. And I don't see it as a different branch or a different implementation of BDD. It's just an expansion on top where you're not, and this is where the next slide is about, and it's like, because when we're talking about BDD, when we're writing our scenarios, we're talking about like a system ability to respond, right? It's like whenever user does this, he should be able to see this. He should be able to do this. We're talking about ability. It's like people are able to get something, but do they want to? And I think this might be the missing piece when we're talking about designing the systems. It's like, are they actually motivated to have this ability in the first place? Because it's very easy to build a system that has ability. It's very hard to build a system that has motivation.
I use the example of economics. It's very easy to design economical formulas for people that behave in pure rationality. It's very easy, and it's also very, very dangerous. I mean, even the young people among us lived through the 2008 crash. It was all because this market, the bloody market, didn't behave as the economists expected. And therefore, I think that BDD has a great promise, and I really like the fact that developers speak in behavioral terms, but I think it also has a big danger because it starts with the assumption the user will behave the way we want them to behave.
Do you not like sacrifice a lot of the immediate feedback though by sort of suggesting that we have to wait till it gets out there before we can even begin to iterate the software?
It's not one or another.
Right.
It's both.
Yeah.
You're not choosing between classical BDD or this. You're just saying the classical BDD misses a bit, so you need to do something in addition to.
I also suggest that this will allow us to generate or to plan and to be more innovative when we design software. We'll add another layer of richness. If you didn't think in this way, or if the Amazon guys didn't think in this way, they would put the pictures and the videos and all the other stuff. I'm not suggesting that I taught them how to do it. They did it way before I even thought about it. But what I mean is that thinking this way will create more rich, more interesting solutions. Sorry.
And the last thing you said before the Q&A was that you hoping this gives a way to more precisely model users before we have the ability to use AI to use unreal users. So where is the source of information? Like, is it purely psychology? Like, if we're taking this approach and trying to model things before we can test them with real users, so it's just like purely empirical psychology.
Who can help us there?
Where do you see the source of information?
So, social science frameworks, these lists, are based on empirical research. So when someone sat and wrote this list of 3 most common human needs. It's based on research and experiments. So you can find, if you're looking for the empirical proof, you can find it. But I would argue that like any other framework or checklist, it's better to have one than not have anything at all. When it comes to actual predictive models, unfortunately, the level of the state of the science, if you like, the state of the art at the moment, is really around biases. Familiar with cognitive biases? Yeah, so this is where you can actually predict. My master degree was on my master research was on the anchoring bias, where you can actually predict. If you present people with a number that will affect just a random number, you can predict in a very high level of accuracy how it will affect their answer about the next question, which will be about a number. Are you familiar with the Wheel of Fortune game? Or yeah. So I did an experiment at Invika, and I think all the Invika guys here were part of this experiment. I presented about 100 developers a list of 10 tasks and asked them to estimate the task, but half of them got the task numbers were random numbers between 25 and 75, and the other half, the other 50, saw the same list, exactly the same context, with numbers randomly between 925 and 975, and guess what? The estimations for the second group was higher. So that's predictable. You can anchor people to think about a number. That's very easy. If you try to utilize it in day-to-day, you only get into sinister solutions. I don't like it. So I wouldn't recommend to start using behavior psychology straightforward into automation tomorrow morning. But I would say that even biases can give you some help in thinking about motivation, because availability bias is a good example. You familiar with the availability bias? So if you think about availability bias is that something that we saw just a few seconds ago affects what we think about the future. So when you think about the process of going from a list to a list to a specific item, the size of the list before you saw the specific item, the size of the category page, if the category page contains a lot of items, and when we jump to one item, we have a feeling of abundance. And if we want to create a feeling of shortage and want people to buy, to be more motivated to buy now, show them less options. And Apple is quite good at that, as we know. They only show us one or two. They only offer one or two variety of something.
But just to rephrase my question, do you see the need of this to model before testing with use? Do you see the need in using it's pure psychology, right? That's where you see the
it's psychology
of modeling before testing with real use.
Yes.
Yes. Just wanted to refer a bit to the previous slide about, you said that at the moment we are just streamlining the user behavior to make it simpler, and I think that's one of the problems of the people related to development field, that they think that's the only way of making the experience simpler. Mm-hmm. And we should think more. Well, we can't think because we are developers, not designers, but the UX bit is really important. Yeah. In the sense of making the experience simpler for users, and removing options is not the only option. The only option really.
And there is this tendency in UX or UI sort of fields to say that the best UI is no UI. Like getting to a point where you don't need to do anything. You just, think about an Amazon where you just think about a book and it shows up on your desk. That's an ideal UI. Well, not really. It will actually be quite freaky. Very efficient, but freaky.
You just tell people what to think first.
Sorry?
You just tell people what to think. The books you have way too many of the warehouse.
Yeah, but I think when people are, we're all people. We don't like when someone tells us what to think. We like to have control. We like to be related to something. we push back. When someone tells us what to think, it may be very efficient. Fascism is a very efficient way of running a country, but it doesn't really survive for long. Thank God. Sorry if I insulted any.
This is where you want to talk code, but like quite a few successfully organised religions that have been around for a few years.
They tell people what to think. Yeah. Again, thank God it's changing. They're losing their powers.
Okay, let the guy possibility to drink.
Guys, thank you very much.